Hey, it's Coach Latham again, and we're back to talk about z-scores. We're going to use z-scores to describe the relationship to the mean by way of talking about standard deviation. We're going to find out how to determine a z-score for an element in a data set, and we're going to solve problems involving z-scores. So let's get right into it. The first thing I want to do is show you a normal distribution. This is not part of your algebra SOLs, but I do think it's important to look at it just to get a basic understanding. If you have enough elements in a data set, it usually ends up looking just like this: the bell curve, the normal curve, the Gaussian curve, whatever we want to call it. And what you'll notice is that the results all seem to bubble up in the middle. In other words, if you have enough data in a set, the individual scores or readings all tend to migrate towards the middle of the set. So you're more likely to get answers that are close to the average value than you are out on the extremes. The reason I'm showing you this is because we have standard deviations marked underneath here. We've got one standard deviation, two standard deviations above the norm. And this is really what a z-score is. If you are right on average, your z-score is equal to 0. If you're one standard deviation above average, your z-score is 1. If you're two standard deviations above average, your z-score is 2. Then you can go below average also. If you're one standard deviation below average, your z-score is -1. And if you're two standard deviations below average, your z-score is -2. I do think it's interesting to point out that between a z-score of -2 and 2, we have roughly 95% of all the scores, which means that we live in the world of z-scores between -2 and 2. 95% of us generally fall in that area. So it's very unusual to be outside of 2 standard deviations from normal. Now, the z-score, well, before we go any further, I do have this interesting matching exercise that will show if you really understood everything I just said. Go ahead and hit pause, play with this for a minute, see if you can match these up. All right, we're back, and let's just go ahead and see if we have a good understanding of z-scores based on my very quick explanation. This first thing up here, we've got the mean listed. Well, if you're exactly on the mean, you're not above or below by any standard deviation. That's a z-score of 0. If you're 2.5 standard deviations above the mean, then you have a z-score of 2.5. And if you're 1 standard deviation above the mean, then you have a z-score of 1. Just wanted to show you what it looks like here. If you're 2.5 standard deviations below the mean, then it's going to have a z-score of -2.5. If you're 1 standard deviation below the mean, then you're going to have a z-score of -1. Between z-scores of -2 and 2, that's 95% of our population. That's what normally happens. And if you're a basketball player with a z-score of 3.5, then you're likely to be a millionaire because you're playing in the NBA. So that just gives you a basic understanding as what z-scores will tell us. Now, this is the z-score formula. Relax. You'll never be asked to memorize that. When you take the SOL test, this formula is on your formula screen. It tells you that z is equal to x minus mu. Now, this is the symbol for the mean of the set right here, and it tells you right underneath here. And this gamma is a symbol for the standard deviation. This x right here is talking about the individual score that you're looking at. Like in this example, we're going to find the z-score for 82, and then we're going to find the z-score for 85. So those are the things that are going to go in place of x. And then z is obviously your z-score. Let's go ahead and do the first one. We're going to find the z-score for 82. So the z-score for 82 is going to be 82 minus the mean of the set. Now, do we know the mean of the set yet? If not, we need to go back and plug these things into the calculator. So I'm going to hit pause and quickly get the mean of the set. Now, fortunately for me, for the last problem, I still had these numbers in the calculator. And remember, the mean of the set is going to be what we have right up at the top when we do our one variable stats. If you are at all confused by this, please look at the previous video on standard distribution and mean absolute distribution, but this tells me that the mean is 82. So 82 is what I needed to know. The mean of this set is equal to 82. So it's going to be 82 minus 82. That's very interesting. Over the standard deviation. The standard deviation was also on that screen that we just looked at before. It's this one right here, 2.366. So we're going to round that to 2.4. Standard deviation is equal to 2.4. And we put a 2.4 right here. Now, 82 minus 82 is 0. 0 divided by anything is 0. So the z-score of 82 is equal to 0. Hopefully that makes a whole lot of sense to you because 82 was also the mean. That's saying literally that we are 0 standard deviations away from the mean. That's what the z-score means. And if we're asking for 82 and the mean is 82, then it only makes sense that we should get a z-score of 0. The next one that we're going to try is z-score of 85. That was the second number we were asked to do. Now it's pretty easy. We've done all the hard work. We're going to find the z-score of 85. The mean is still 82. The standard deviation is still 2.4. And we're going to plug all this into a calculator and see what we get. 85 minus 82 is 3, and we're going to divide 3 by 2.4. I am going to consult my trusty calculator on this one to do that division. I've got 3 divided by 2.4, and my answer is going to be 1.25. So the z-score of 85 is 1.25, and that tells us that 85 is above the mean by a little bit more than 1 standard deviation. Remember, the mean was 82, so 85 is going to have a positive z-score. My next problem right here, it says find the z-score for 80 in the following set. So this is exactly what we just did. You're going to try and answer that. And then I want you to think a little bit and tell me which score in this set has to have the lowest z-score, and then find out what that is. So I'll hit pause right now so you can do the work on this set. Okay, we're back, and we were using the same set of numbers, so we kind of know from the last problem or from consulting our calculator that the mean of this data set is still 82, and the standard deviation is still 2.4. So using the z formula, or the z-score formula, if we want to find the z-score for 80, then it's going to be 80 minus 82 divided by 2.4. We do some simplification, and we find that the z-score for 80 is equal to negative 0.8. And that makes sense to us because 80 is below average. Remember, the mean was 82, and so we have to get a negative z-score for that. Now, for the second part of the problem, you have to think just for a bit to figure out what we're going to take the z-score of. It says, what score has the lowest z-score in the data set? Well, it's always going to be the lowest number in the data set that's going to have the lowest z-score. And if we were to ask you the opposite of this, 85's got to have the highest z-score. And the z-score for 85's got to be positive because it's above average, and the z-score for 76 has got to be negative because it's below average. So we figure out that 76 is the one that's going to have the lowest z-score. It's going to be 76 minus 82 divided by 2.4. That's going to give us negative 6 divided by 2.4, which is negative 2.5. So the z-score for that is negative 2.5. All right, we're almost done with this unit, but the last thing I want to look at is some problems that you might see on the SOL test related to the z-score. Sometimes they don't give you the data set. They give you a bunch of different information, and your job is to fill in what they give you, figure out what's missing, and then figure that part out. It's really an exercise in solving an equation. But anyway, we'll take a look at this problem right here, and then I'll have you try an example. It says if the z-score of 16, so 16 is our actual score, so 16 is x for this one, is negative 8, so the z-score is negative 0.8, I should say. So the z-score is negative 0.8. I'll go ahead and write that right there. And the mean is 19. Well, they're telling us that the mean is equal to 19, which goes right there. What is the standard deviation? So in other words, we know everything in this formula except for the standard deviation. If I write this a little bit neater, I get negative 0.8 is equal to 16 minus 19 over the standard deviation, which we don't know. Well, we can do 16 minus 19. That's pretty easy. So that gives us negative 0.8 is equal to negative 3 over the standard deviation. Now, we can't solve this when we have standard deviation on the bottom of a fraction. So we're going to multiply both sides by standard deviation. I know my standard deviations start looking a little stranger and stranger. These two cancel out. Just gives us a negative 3 left on this side. And over here, we got standard deviation times negative 0.8. I'm going to rewrite that as negative 0.8 gamma, standard deviation, even though it looks like an afflicted 6. To get that gamma by itself, I'm going to have to divide both sides by negative 0.8. And this stuff is all going to cancel out over here, just giving me standard deviation. And I consult my friendly calculator to do negative 3 divided by negative 0.8. And I get 3.75. So the answer is that the standard deviation for this problem is 3.75. I've made one for you to take a look at that's very similar. You're going to substitute in the information that you know and solve for the missing piece, which in this case is going to be the mean. So I'll hit pause, give this a shot, and we'll check back in with the final answer. All right, we'll go ahead and finish this one off. It tells us if the z-score of 500, so that's the score right here, is 1, that's the z-score right here, and the standard deviation is 100, so that's this one right here. I wrote it down here also. Standard deviation is 100. What is the mean of the set? So this is the only thing we don't know. So we'll go ahead and write our formula a little bit more clearly. 1 is going to equal to 500 minus the mean that we don't know divided by the standard deviation, which we said was 100. Now the very first thing I'm going to do in this problem is I'm going to multiply both sides by 100. Over here it's just going to cancel that out. And then 100 times 1 is 100. So I'll go ahead and skip on down here. 100 is equal to 500 minus the mean. So now to get the mean by itself, I'm going to subtract a 500 from both sides. That's going to give me negative 400 is equal to the negative of the mean. I'm going to multiply both sides or divide both sides by negative 1, whichever way you like to say it, to get rid of the negative sign. So the mean is equal to 400. So there's our final answer on that one. Make sure that you consult with your teacher to get some extra practice problems in preparation of the SOL test. Hopefully this has been helpful. This has been Z-Scores in under 15 minutes.